This video is going to help you with your second final exam CR review. I think it might be CR 34. So it says if the line contains the points, this is for number 1, if the line contains the points on the table below, the equation of the line is. All right, when we're talking about equations of the line, we're talking about y equals mx plus b. That just means y equals some number, and that number will be the slope, times x plus some number, and that number will be your y-intercept. The y-intercept is where we cross the y-axis. So if you consider an xy axis, the y-intercept will be some point here where we're crossing the y-axis. Our line might be going up like this, our line might be going down like this. But the important part about the y-intercept is the x value there will be 0. You don't move anywhere left or right. Let's say you move up 2. Or in our case, 0, -2. Because in terms of the y-intercept, as soon as I have an x value of 0 as a coordinate, I know that has to be my y-intercept. So I already know right now from this that b equals -2. This has to be my y-intercept because the x value is 0. That has to be where I cross the y-axis. So now I just have to find the slope of this line. We know our slope formula is y2 minus y1 over x2 minus x1. I can choose any xy values in my chart here. Now, I'm going to be honest with you, there's negatives running all over the place, so I'm just going to call this x1, y1, and I'm going to call this point x2, y2. So -2 will be our x1, -12 will be our y1, -1 will be our x2, and -7 will be our y2. I'm just going to substitute into the formula. y2 minus y1. So -7 is y2 minus, because of the formula, and our y1 is -12. Over our x2. Our x2 is -1 minus from our formula, and our x1 is -2. All right. Minus a negative becomes plus. Minus a negative becomes plus. So what I'm really talking about here is -7 plus 12 over -1 plus 2. And I look up in the numerator. Are those signs the same or are those signs different? The signs are different. I'll find the difference. The difference between 7 and 12. 7, 8, 9, 10, 11, 12, 5. What do I have more of? I have more positives. The larger number is positive. In the denominator, signs are different. I'll find the difference. The difference between 2 and 1 is 1. What do I have more of? I have 2 positives, so I have more positives. So my slope is 5 over 1, or 5. So this right here is my m value. So now I have my b, I have the m, and so I have y equals mx plus b. Y equals, in place of m, I would put 5. Times x, and in place of the b, I would put -2. So I could write plus or -2 or just -2. So this is going to be a really steep line. It's going to be a really steep line, and it's going to cross at 0, -2. So it's going to be a crazy steep line. I know that because of my change in y over change in x. I got to go up 5 and right 1. Up 5, right 1. Down 5, left 1. Okay, that's the ugliest line I've ever drawn, but that's kind of a visual about what our line would look like. So there you have it. That's number 1. Let's move on. And then you just see which matches that, A, B, C, or D. You can do this. Next one. Which value of x is the solution of 2x over 5 plus 1/3 equals 7x minus 2 over 15? Okay, the first thing that shouts out at me is, oh gosh, there's fractions. So if I want to add and I have fractions going on, I'm going to find a common denominator. So as I look at this side, I'm like, okay, if I want to add these, I have to find a common denominator. So I'm going to take the original, 2x over 5 plus 1/3 equals 7x minus 2 over 15. My x is so ugly. Okay, so I'm going to find a common denominator. What's the common denominator between 5 and 3? Oh, 15. So I would have to multiply 5 by 3. I'd have to multiply 2 by 3. Over here, I'd have to multiply 3 by 5. Here, I'd have to multiply 1 by 5. 2 times 3 is 6x over 5 times 3 is 15. Plus 5 times 1 is 5 over 3 times 5 is 15 equals 7x minus 2 over 15. Really, now that all my denominators match, I can actually eliminate my denominators. This is very similar to when you say, oh, you have a system of equations and you want to multiply the entire equation by some value. Well, I could multiply each term by 15. And if I do that, it'll eliminate the denominators, because if I have 6x over 15 and I multiply that by 15 plus 5 over 15 and I multiply that by 15 equals 7x minus 2 over 15 and I multiply that by 15. That's all I'm doing, multiplying 15 by each term here in this equation. Well, 15 divided by 15, oh, that's a fancy form of 1. 15 divided by 15, fancy form of 1. 15 divided by 15, fancy form of 1. All right, I've just eliminated the denominators. So now I have 6x plus 5 equals 7x minus 2. And you can solve this equation. We're going to move all our constants to the right-hand side, all our numbers without x's to the right, all of our x's to the left. So I'm going to subtract 5 on each side. And I'll have 6x equals 7x. Negative 2 minus 5. Signs are the same. I'll find the sum. I'll keep the sign. 2 and 5 is 7. Keep the negative sign. All right, now I'm going to move all my x's to the left. So I'm going to subtract 7x on the right, subtract 7x on the left. Bye-bye. 6x minus 7x is negative 1x equals on the right-hand side negative 7. Then I say, what's the operation between the negative 1 and the x? Oh, that's multiplication. How do I undo multiplication? Division. I divide both sides by negative 1. Whatever's in front of the x here, the coefficient of x, negative 1 divided by negative 1. Bye-bye, fancy form of 1. X equals negative divided by a negative is a positive 7. So x must be 7. Okay? So if I substitute 7 in place of the x values, both sides of this equation would be true. And you can do that. You can substitute the x in. 2 times 7 is 14/5 plus 1/3 equals 7 times 7 is 49 minus 2. 49 minus 2 is 47 over 15. Common denominator here. Common denominator here. I know I'm squeezing in. 14 times 3 is 52. I'm guessing. Ooh, I hope so. No, can't be. 14 times 3. 42? 42. Sorry about that. 14 times 3 is 42/5 plus 5 times 1, 42/15. 5 times 1 is 5/15. And you put those together and you definitely get 47/15. I've really done not a spectacular job on this problem, but I believe in one take and calling it a day. So, and 42 and 5 is 47 over 15, which is what we needed to come up with. All right, let's move on. Which equation represents a linear function? For each choice, explain why or why not it represents a linear function. Okay, so for letter A, the issue is we cannot have x down in the denominator. Can't have x down in the denominator. So this is not linear. It's called non-linear, which just means it's not linear because x is in the denominator. Next one. The issue here is that the exponent is a 3. To be linear, you have to be able to be rewritten in the form y equals mx plus b. Some number times x plus some number. So the exponent here on this x is a 1. We could have sometimes where the line is just y equals 5, and then the exponent on the x would have been a 0. But those are the only two exponents allowed on the x variable in order for this to be linear. So you need an exponent of 1 or 0 on the y, an exponent of 1 or 0 on the x. So an exponent of 3 doesn't work. This is cubic, so this is nonlinear or not linear because exponent on the x term is 3, while the exponent on the y term is still just 1. This one right here looks like I'm going to be able to rewrite it in this form because I can already see the exponent on the x is a 1 and the exponent on the y is a 1. And if on your variable parts the exponents are 1, it's definitely going to be able to be linear. I can show you how we can rewrite this. We could subtract 2x on both sides, and that would give us 3y equals, subtracting 2x, those are gone. I can't put these together. These are not like terms, so that's negative 2x plus 7. I could then divide each piece by 3. It's an ugly final equation here in y slope-intercept form, but it works. So this would be y equals negative 2/3 x plus 7/3. Totally linear. I was able to put it in the correct form. So this one is the linear one. And the reason is exponents on the x and y variables both have 1. And if both of your variables have an exponent of 1, you know you're guaranteed to be linear. Next one, here's the issue. We can't have an exponent of 1/2. So this one is nonlinear. Exponent on the x variable is 1/2. It would have to be a 0 or a 1 in order for it to be linear when you have the exponent on the y being a 1. So that's a quick little review of linear versus nonlinear. Let's see what the next question looks like. I might be able to squeeze this question in. Which of the following choices represents a function? Okay, to be a function, each x value can go to one and only one y value. Each x value can go to one and only one y value. So, for instance, on this first one, we want the one that does represent a function. You can't have 0 trying to, I'm going to look at the x values. You can't have 0 trying to map to 5 and 3 and 1 and -1. You can't have, that's supposed to be a -1. You can't have your x value trying to map to all those y's, because here if I have 0, it's like, oh, am I going to choose to go to 5? Am I going to choose to go to 3? Am I going to choose to go to 1? Am I going to choose to go to -1? That one's definitely not a function because 0 is trying to map to a bunch of y's. Next one, let's see. 1 is mapping to 2. 3 is mapping to 2. 5 is mapping to 2. And 7 is mapping to 2. Now this is fine because here 1 only maps to 2. 1 doesn't try to go to anything but 2, and I can plot that 1, 2, and then 3 to 2. So I can plot over 3 up 2, 5 2 over 5 up 2, 7 2 over 7 up 2. Okay, this is actually a beautiful line here. Happens to be a horizontal line, and it will be a horizontal line, and what happens? Each y value equals 2, and that's totally fine. You could do your vertical line test, and every time I draw a vertical line, I'm going to hit that function at one and only one spot. So that's definitely the function. Next one, why is c not a function? Well, 1 tries to map to 3, and then 1 again over here tries to map to 5. You can't have x trying to pick 2 different y values. It's not allowed. It would fail the vertical line test. And again for letter C, 2 tries to map to 4 and to 6. Each x can map to 1 and only one y. All right, that one doesn't work. Let's take a look at why this one doesn't work. Well, again, if I look at the x value of 1, 1's trying to map to both 2 and 1. And that's a problem. Your each x can only go to 1y. 3 going to 3 would have been fine.